Hey everybody, so this is the overview of your spreadsheet 2 assignment for week 4 of our class. So I'm just going to jump right in, share my screen. So you're going to be working on this elephant data, which you should download, or when you're prompted on Blackboard, you will be asked to make a copy of it. So I'm going to make a copy here and just remind you that you can, when you make that copy, you can put it in your own folder so that you can find it. And you really want to put it someplace that you can find it because we are going to use this next week too. So once you copy it, remember it comes with this little folder right here that it gives you a prompt to move it, or that gives you the ability to move it to where you want it. Okay, so when you open this up, you should see that I've already created a cover sheet. And the cover sheet is describing what this data is. So we got this data from Dr. Joyce Poole, who is an expert in elephant biology. And what she's been doing is collecting data on elephants in this part of Mozambique that experienced a pretty terrible civil war from 1977 to 1992. And during that time, nearly 90% of the elephants were wiped out in Mozambique. And they were mostly wiped out due to poaching. People would poach them for the ivory of their tusks, take their tusks, sell the ivory, and use that to buy weapons for the war. So it really had a devastating impact on the elephant population during that time. This is one of those examples of overexploitation as a risk to species survival. But one of the things that is a result of that likely is a change in the elephant population. So we haven't talked about evolution in this class, but the basic principles of evolution you may remember from your high school class, right, in biology, which is that a population changes as a result of selection. In this case, we would call this artificial selection, but it's the same process as natural selection, which is that there's a higher rate of survival for certain individuals with certain characteristics compared to other characteristics. So individuals who had very large tusks were selectively removed from this population so that the survivors tended to be individuals who had small or no tusks. They were less likely to be shot for poaching. So they survived and provide the seed for the current generation. So the current generation, which actually is measured in 2005 to 2013, so we're already 10 years ago, was the descendants of those survivors. And this generation from 1966 to 1968 was present before, individuals that were measured before this event, before the Civil War. So this data includes the sex of the elephant, the approximate age based on size generally, the height of the elephant, the tusk length, and the tusk circumference. So these two data sheets represent data from before the Civil War and data from after the Civil War. I put a note in here about something that we're going to calculate. It's a little bit complicated, so I wanted to use this data to show you how to make a calculation within Google Sheets. But we're using circumference and length of the tusk to get volume of the tusk, and that is not as simple as getting the volume of a cube. So you don't have to know the math here, but I wanted you to see what the math is. Like, in order to go from the two measures we have, circumference and height, to actual volume, we have to do a couple of modifications. We have to do a couple of calculations. It's not a simple multiplication. But either way, like, it doesn't really matter what the underlying math is. What we're doing is trying to get the volume. Okay, so let's start by doing our usual hygiene. So hopefully you've put the file somewhere that you remember it. We're going to work in this video. We're going to work on this 1966 to 1968 data, but you will repeat what we're doing now in your assignment for the more recent data. So when you turn this in, it should have both what we are working on together here through the video, and then your own efforts to do the same thing in the next data sheet. So we're going to need a working copy of both of these. My Zoom dialog is in the way here. So remember to do that. You click on the down arrow here, and you get a command to duplicate. So we want to duplicate this. and I'm going to call it working copy of 66 to 68. And I might as well just duplicate this now. So that I don't forget to make a working copy later. And we're going to call that the working copy for these years. I'm going to just shove those next to each other for my own convenience. Okay, so my working copies are here. And the other thing we want to do is freeze our first row, and we do that with the view menu, and we can freeze the top row. Oop, and I'm not in the working copy. How about that? So we're going to freeze the top row for both of these. That's a view, freeze, one row. Okay, so what we're going to do with this data is a couple of different things. We want to calculate this new value of tusk volume from the tusk length and the tusk circumference. Actually, you'll notice when you open this up, of course, the first bunch of rows are missing that data. That's okay. That just means it wasn't always collected from every animal. So there's going to be some missing data here, and that's going to be useful to think about as we move forward. I'm not sure why I have this here. I'm just going to delete it. Make sure that's gone from your own copy. Okay, but our first calculation here is going to be taking the tusk circumference value and converting it to a radius. So we're going to call this tusk radius. And we want that in centimeters because we're calculating it from the tusk circumference in centimeters. And to do an equation in Excel or in almost any spreadsheet, you usually start with an equal sign. So what we wanted to do, actually, I'm just going to move this down so you can see it with an actual number in the cells. So we're going to take the tusk circumference and we're going to divide it by pi, 3.14. So that is the actual, that helps us convert circumference to radius, which is, if you remember from geometry, is half of the diameter of a circle. So that's that number. Now in Google Sheets, you often get the suggested autofill. It looks like it's doing the same calculation for the whole. I'm not sure why that's the case. What did I do here? Oh, I've got it in the wrong box. Look at that. So when we make this calculation, I want to make it in the box where the number is going to be. So now we're going to do this again. Equals the tusk circumference divided by 3.14. That gives us this new radius value. And to get it through the rest of the data, I think we talked about this, but if not, when you highlight a cell, you often have this little, you should have this little thicker portion of the bottom right corner here. This is called the handle. And we use that to drag an equation, a calculation, up or down in a column or across along a row. You can do it either way, but we're doing it this way. We're going to drag that down all the way to the bottom of the data. This is a lot of rows. And that's giving us a tusk radius value that is the same equation. This cell, the cell that's next to it, divided by pi. And every time I move, you can see that this address changes for the originating cell, right? So because I started not quite at the top, so that you could see an actual number calculated, I'm just going to go back up. These are all going to be zeros, but I'm going to fill it in so that we have the whole column filled in. Okay, so now we have tusk radius. Now we want to use the radius and the circumference and the length to get the tusk volume. I'm just going to make this wider. I'm going to call this tusk volume. And this is in centimeters cubed. So it's like a cube. And we want to, again, make an equation. So we're going to use an equal sign. And we want to multiply length times. So the times here is the asterisk. Circumference times radius gives us the actual, times radius, and then hit enter. And that gives us the actual value. So now, because I started at the top of the column for this, it's giving this suggested autofill. You can check down to see once we start to get numbers like, yeah, that looks right. Oh, I didn't hit enter, so I didn't get what I needed. Let's go back there. Oh, darn it. So if you check the autofill, you'll fill in the whole sheet with these numbers. So this is going to go down to 500 something. Okay. So that allowed me to create a new calculated column. So really what I'm wanting you to learn here is that you can make calculations in a sheet. You do that by using the equal sign and creating an equation that does the calculation you need. And then you can repeat that calculation in a column by dragging the handle down, or in a row, if that makes sense, by dragging the handle across. So these are useful tools when you're learning how to use these programs. Okay, so that's one thing you're going to do. So now you're going to do this on your own for the data for 2005 to 2013. Okay, the next thing we want to do is calculate some summary statistics, and we do this with a pretty cool tool in these spreadsheets called a pivot table. So to make a pivot table, you want to select the whole sheet. And you do that by clicking on this corner between A and 1. And you want to go to the insert menu and insert a pivot table. This will ask you if you want it to be a new sheet, and I think that's a good idea. So I'm going to create a new sheet, and I want to name it right away so I don't forget what it is. So I'm going to rename this as Pivot of 1966 to 68. So I don't forget what the origin was. Okay, so what do you see here when you see a pivot table? You have this strange box, and then you have this editor over here. What a pivot table allows you to do is take data that is in different categories and sort it. So the kinds of information that we want on this from this pivot table is we want to separate the males and the females from each other. So you can see they're kind of mixed together. And we want to be able to see just for their tusk length, we want to know these different values. So we want to know some values of their central tendency. So we just learned that vocabulary recently. The central tendency, which is the mean, the median, and the mode, which we'll get to in a little bit. And then we want to know some measures of dispersion, like how widely spread the data is. So to get to one way to read dispersion is to get the range. To get the range, you need the maximum and the minimum values in the data set. And another more statistically described way is the standard deviation. So we're gonna use the pivot table to calculate all of these values for tusk length. So let's go to our pivot table. So the first thing I want to do is separate males from females. So I am going to make two columns based on the sex of the animals. So we're going to grab this title, sex, and we're going to put it under columns. Okay, so now I'm going to have all of my data separated into female and male columns over here. And then all of this information was on tusk, right? What did I want? Tusk length. So we want to take the tusk length, and we're going to make that the values that we're going to calculate. And what you can see is that the values, so this value, now I've pulled over how many of each, this is summarizing all of the data. So there's 436 lines of data that have a sex identified for the animals. 230 of them are F, female, and 206 of them are M, male, right? So that's that description. I never am really sure why there's this first row here, but we're just going to ignore it. So The thing about pivot tables is that they're a little bit, they can be a little bit wonky to read, but as you become familiar with it, you'll start to see it. So that gave me a count. So that is actually on our working copy. That's actually one of the first questions we have is what is the sample size? So you can put those numbers in. So it's 230 females and 206 males. Another way that you can put the data in is to copy and paste it. I just want to show you how that works. So if you just control copy or use the edit function to make a copy, and then go to our working copy and put that number in. Oh, that worked fine. So sometimes it gives you an error because it's relating to the pivot table. So I think it's worthwhile when you copy numbers from a pivot table into a data sheet is instead of just using Control V or the standard paste, go to the edit menu and paste it special. So go to this direction, paste it special, and paste it as a value. And then it's not like linked anymore to the pivot table. So if you change the pivot table, it doesn't get lost. That's really the main thing. Okay, so let's go back to our pivot table. So we have the count. We want to know the mean. How do we get the mean from a pivot table? Actually, it's because the way you can is that all of these, there's a whole bunch of different ways that you can summarize your data. So if you click on this down arrow, you can see that there's, you can get a sum of all of that information. You can get the count. You can get an average, which is the same as the mean. You can get the median, which is another one that we need. You can get the standard deviation, which is another one that we need, and maximum and minimum. So everything that's on that table that is on the working copy, mean, median, minimum, and maximum, all of those numbers you can generate just from the pivot table. So you could just change, you can just change the identity here to average, and that'll give you a new number. Again, you can copy and paste that. Let me see if it changed it. This is where the problem is. No, okay. So Google has gotten smarter, or the Google Sheets has gotten smarter than it was. So I'm gonna copy this. Oh, I accidentally pasted it. Copy that, go back to my working copy and paste it special. Even though I think it'll be okay, I really just want to make sure that the value is there. Okay, so you can do that with mean, median, sorry. Or if you want to recreate the whole table, you could actually just keep pulling this down. So you know that, oh, that's right, it doesn't make it rows. Let's see if it'll make it rows. No. Yeah, I think the easiest way to do it is just to do what I'm doing here. So change the value here to, from count, you want average, you want the maximum value. So you get these two. That's going to go in for, oh, maximum would go here. You want the median value was the next number. So that would go in your table here, median for male and female, or female male. The minimum is there. So that value is going to be there. Actually, we need those numbers. So I'm going to copy that. Let me get my maximum value now. I'm breaking my rule here and not pasting them as values because I'm just working quickly. And then the range is just going to be the difference between these two. So for the range, you want to put an equation in, and you're going to subtract from the maximum value the minimum value. And that gives you the range, the spread of the data. So same here, you're going to do the maximum minus the minimum. So those are so mean and median are measures of the central tendency. Range, minimum and maximum are there just so that you can get the range. The range is a measure of the spread. And then standard deviation is a different measure of the spread. And again, the pivot table can generate that for us. So we just go to tusk length and we choose standard dev, step dev, and you get these two numbers, which are our standard deviation. So what you can see is that a pivot table is a very effective way for generating really these simple statistics of the simple summary statistics that you want for any given data set. I did want you to calculate mode because it's a little bit, it's a different way. There is a way to do it in this system in Google Sheets. But it turns out that tusk circumference is a tough one to get mode from because the values are like, I'm sorry, tusk length. The values are more, there's more spread out. So there's fewer values of tusk circumference, and that helps us see how mode works a little bit. So we're going to go back to the pivot table, and instead of using tusk length, I get rid of this. I want to do tusk circumference. And I want the tusk circumference to be the rows in my column here, because now I have all of the possible circumferences that have been measured in both males and females. And then I can do for the values, what is the count of every circumference in both sexes. So this is a way to look at what is the most common value for circumference in these two sexes. Actually, I only asked you to do the females, so we can ignore the males. So we will take this data. One way to look at this is actually pretty slick, is to collect all of the data. So highlight all of the data from those two columns, and then insert a chart. And the chart that we want is so this is a little bit confusing because it's using, all right. Well, I mean, the numbers that you want to determine which is the most common size are these ones that are sort of shaded out here. Why is this giving me this? I think this has something to do with counting up these numbers and putting them on the same chart. So I'm sure I can modify that, but I don't really need to. Let's see, let's give it another try. How would we do it? Can we get rid of this column? I hid that column, and now I'm going to do just this. And we'll try it again. And I want it as a column chart. Yeah, okay. So I just had to hide that column that started with 0, and I don't know why that's in there. But what that does is show me that this is basically the count of all of these different measures. So all these different circumferences in the female population. I can see that the tallest one is this one. There are 14 females who had a tusk circumference of 22 centimeters. So I can put on my working copy that the mode for female tusk circumference was 22. That was the most common measurement. The other thing that you can see, or the other thing that I would like you to just practice with, is putting in a chart that's a histogram, because it also shows you how the data is spread. So we're going to go back to our tusk length, and we're going to highlight this whole column, and you want to insert a chart. Oh, and this just automatically went to a histogram, but over here, what you'll see is that this histogram chart, these are the choices that you have. So I guess I didn't say that when we were looking at the mode. So when you put in a chart, you have the choice up here. What we want here is the histogram to see how the data is spread sort of visually. So again, this is, if you remember from our definitions, this is pretty close to a normal distribution, but it's a little bit skewed to the small side. So there's a few very large elephants that have very large tusks in this time period, but most are kind of centered around a middle point. So, so your assignment is to do this to do these manipulations where you're making the calculations to calculate tusk volume, and you're using the pivot table to generate these numbers, all of these numbers from the pivot table, and the tusk circumference, and the mode, and you're going to insert a histogram. And you're going to do that now for 2005, 2013 for those individuals. So that's the homework. The other part is that, remember, at the end of this, you want to make it shareable. So you're going to say that anyone with the link can be an editor. You're going to copy that link and enter that into the Blackboard text submission for this assignment. All right, so that's it for this week. That's your second spreadsheet, getting a little more familiar with how to do equations in Google Sheets, and a little bit about how to do graphs. But we're going to spend more time next week talking about graphs. All right,